Hello people, the question is from GATE 1996 exam. They're asking what is the worst case multiplier for Booth's algorithm. You have these four options. Now in my theory lectures, I've already discussed that Booth's algorithm prefers such multipliers in which you have continuous zeros or continuous ones. You can see all of these three options have continuous blocks of zeros or continuous blocks of ones. So these are good inputs for multipliers of Booth's algorithm. Okay. Option A is the worst case because you have alternating zeros and alternating ones. See, 1, 0, 1, 0, 1, 0. This is worst input of a multiplier for Booth's algorithm. Now let's discuss why is this the worst case. Okay. First thing is you need not calculate the number of operations for each and every option in this question. Here it's clearly visible that this will be the worst case because see, in option C you have only one block of ones and each and every symbol is part of this block only. Okay, here you have a block of zeros, then a block of ones and a block of zeros. Okay, here you have the most number of blocks and each and every block has minimum number of symbols. So this is the worst case. Now let's also calculate number of operations for each and every option. The option which has most number of operations performed will be the worst case. Okay. So let's analyze option A first. If we convert this pattern into 8 bits, you will get 1 0, 1 0, 1 0, 1 0. Okay. Now to find number of operations, step 1 is you append a 0 to right hand side of this number. Whenever the change is from 0 to 0 or 1 to 1, you will output 0. Okay. And whenever the change is from 0 to 1, that means, for example, here, if current bit is 0 and next bit is 1, you are going to output -1. Why -1? Because a block of ones is starting. From this point, a block of ones will start. If you have a change from 1 to 0, you will output 1 because from this point, a block of zeros is starting. If the change is from 0 to 0, that means no new block has started. Just output a 0. Similarly, for 1 to 1, output a 0. Now, if current bit is 0, change is from 0 to 0. That means no change, so output 0. From 0 to 1, you are going to output -1 because a block of ones has started. And actually that block ended here only. From this point, a block of zeros is starting. 1 to 0 means output 1. Okay. So I have written this Booth's coding for this input. I hope you know how to do this. Anyways, I've just explained it quickly right now also. Now you see, you have 3 plus 1s and 4 minus 1s along with 1 0. 3 plus 1s indicate 3 additions have to be performed. So in option A, you require 3 additions and 4 subtractions. Okay. That means in total 7 operations will be performed. Okay. Now, Booth's algorithm actually requires 3 kind of operations: shift, addition, subtraction. Shift will not be considered. We are only considering addition and subtractions because shift is very easy to perform. Shift does not even require ALU. Shift can be performed inside of the register only. Okay. Moreover, shift is very fast as compared to both of these because the operands need to be moved to ALU in this case, okay, in addition or subtraction. So we are not comparing on basis of number of shifts. And moreover, if all of these options are of 8 bits, each and every option will require 8 shifts for sure. Okay, so shifts are actually equal. So I'm just considering number of additions and subtractions. So 4 subtractions, 3 additions. Now let's analyze option B. See, in option B, you have a continuous block of zeros. That means number of operations will be very less. It is 1 followed by 6 zeros. Then again 1. Now we'll add an imaginary 0. 0 to 1 means a block of 1s is starting. You are going to output minus 1. 1 to 0 means a block of zeros is starting. You are going to output 1. Okay. Now see, this block of zeros continues till here. That means for every pair you will keep on outputting 0 only, because we are in that same block only. Okay. See, 0 to 0 means no change. So output 0. Here also output 0. And then output 0 for each and every pair until you see 0 to 0 transition. Now we are seeing a 0 to 1 transition. That means a new block of 1s are starting. So we are going to output minus 1. Look, in option B, how many operations will be performed? 1, 2, 3. Actually, you will have minimum 8 shifts, but we are not discussing about shifts. It is 1 plus 1, 2 subtractions. So it is 2s and 1 addition. Okay, 1a. So here we had 7 ALU operations. Here you have only 3 ALU operations. Okay. Similarly, you can see what about option C and option D. What I can tell you is option C will surely have less than 7 operations. Option D will surely have less than 7 operations. Hence, option A will be the worst case. You don't need to perform all these calculations and count the number of operations. It's clearly visible that there is not proper pattern that is required by a multiplier in Booth's algorithm. Booth's algorithm is designed to exploit the fact that continuous ones can be replaced by zeros. Okay. So you don't have continuous ones or zeros in option A. That is your answer. Okay.